Welcome to Uppsala University and to Uptalk Weekly. My name is Lina Source Emilsson. I'm your host at this popular seminar that is organized by the Faculty of Science and Technology. Uptalk Weekly is created to give alumni and everyone interested an opportunity to learn more about the research being conducted at our university, to meet our researchers and ask questions. Your questions can be asked in the chat, and I will bring as many as times allow to our guest in the end of the session. Today we will meet Ginevra Castellano, professor in Intelligent Interactive Systems at the Department of Information Technology. Ginevra is the lab director at the Uppsala Social Robotic Lab, a lab that aims to design and develop robots that can learn to interact socially with humans and bring benefits to the society in areas such as education, e-learning, healthcare, and assistive technology. The research and development of robotics that Ginevra and her colleagues are conducting is increasingly important, since robots, like all technologies, may not only bring benefits. In fact, robots can change how we think and how we behave, for good or for bad. So one of the main questions is, how can we develop human-centric robots and still preserve human agency and autonomy? Welcome, Ginevra.
Thank you very much for the introduction, Lina. I'm very happy to be here today.
So, Ginevra, your research interest is in intelligent interactive systems. Can you tell us a little bit about it and about your professional journey that brought you to this field of research?
Yeah, so I will say a few words about myself. First of all, I'm a professor now at the Department of Information Technology, but I'm originally from Italy, and I have received my PhD from the University of Genova in 2008. And then I have moved to the United Kingdom, to London first, and then Birmingham for a postdoctoral position and also a researcher position. I moved to Uppsala in 2014 as an assistant professor, where at that point I founded the Uppsala Social Robotics Lab. And now I am working with social robots. So that's my research interest that I have worked on for more than 10 years now.
So, intelligent interactive systems, what are they? What is that?
Yes, so my title is a little bit broader than just social robots, but social robots are an example of intelligent interactive systems. So we are talking about robots that have to some extent some level of intelligence. They can interact in the real world with people, they can plan actions, and they can support humans in a number of different ways.
So when you talk about intelligence and robotics, you mean that they are able to interact and respond? Or what? How do you define intelligence here?
Yeah, so we think about systems that are capable of interacting with the environments through perception of the environments, and then through actions generated in the environments in accordance to certain goals. So yes, there is to some extent the ability to perceive what's surrounding us and to make some interpretation in order to plan some actions in broad terms. So social robots can do that too.
So for someone who's never seen or heard about a social robot, could you share a picture or something to give a little bit of a vision of it? Yes. And explain a little bit more in detail about social robotics?
Yeah, so here you can see a few examples of what a social robot could look like. So, and as you can see there in these four pictures, these robots look quite different from one another. But they have something in common, all of these robots. And what they share is, to some extent, the human-like appearance. So all of them have a head, more or less human-like. Some may have arms, some may have legs. And some of these human characteristics are what define social robots, as it is one of the main requirements to be able to interact with humans in the real world in ways that resemble human communication. So if you look at these bodies, you will expect that these robots might be able to look at you, to point with their hands, or to move or to smile. So these social aspects in their body, in their physical body, it enables them to interact also with us in a way that is perceived as socially acceptable or socially intelligent.
If you define sometimes, if we just back one step and talk about a robot, what is a robot?
Well, a robot in general is a metal box with wires, with gears, with motors. It runs on electricity. It has a computer on board, and there's some software that enables the robot to act in an environment. That's very roughly what a robot is. And these metal boxes can look in different ways. So social robots have a kind of human-like appearance, as what we can see in these slides.
Thank you. So let's just sum up a bit. A robot is an artificial intelligence or a computer system with a physical entity. Is that what we can say? And if it's social, it also has appearance and can socially interact.
Precisely, but the social appearance is not enough, as you have mentioned. There needs to be some form of intelligence, of artificial intelligence, in order to enable these robots to interact successfully with humans. So what does this mean? If we think about the idea of a robot that interacts with humans in a kind of social interactions, these robots, first of all, need to be able to understand that they are interacting with a person, that there's a human being in front of them. They need to be able to understand what these people are saying, how they are behaving, what are their intentions. But also at the same time, it is crucial the robots make their intentions known to people. And that's also crucial when it comes to designing and developing robots that are truly human-centric. So the human beings need to be at the center of the design and development process if we want robots that really work for us.
So human-robot interaction, what does it mean for you? What is a human-robot interaction?
We study robots that interact with people, and that means in my specific research, robots that interact with people in socially assistive roles. Think, for example, about robots acting as instructors for children in the classroom, or instructors in the factory, robots acting as personal assistants for the elderly, or in hospitals for healthcare personnel, game companions for children in entertainment applications, or also tools for therapy and rehabilitation. So this goes beyond the ability for robots to support humans in physical tasks, such as fetching or carrying objects. There is a work that studies the ability for robots to interact naturally with humans. That's at the base of designing robots that can also support us in a social way. Think about supporting children throughout learning, encouraging them if they are experiencing difficulties, motivate people towards behavior change, making sure that someone is sticking to their diet or their rehabilitation exercises. So things like that. So there is a kind of social support role that these robots can play. And that's what I study as well in the research that I do.
Do we know today what is required for a robot to have so that a human being will accept them as an interacting partner?
That's a very important question, and also a question that is still open. If we think, for example, about questions surrounding the idea of human likeness and human form. So should a robot really look like the ones that I've shown you? Should they really have a human appearance? Should they have a face? Should they have eyes? And how human-like should they be? Should they really look like people in the case of Android robot, for example? Or is it sufficient that there's some kind of basic basic face with maybe just the eyes looking at you. So this is a question that is still open, and it's at the core of my research. How much human likeness do we need for people to engage with robots? But human likeness is a concept that extends beyond the physical body, and what we have seen in that slide. When I talked about social intelligence behavior, we can think about human likeness in social intelligence behavior. So should we look at humans and how they behave in interaction, and in order to develop behaviors for robots? And what happens if we don't do that? How context dependent is it? And also how culture dependent is it? So there is clearly research pointing in that direction, but we still don't know how much we should, let's say, mirror from the human world, because we also know that the human world is biased in many cases. So we don't really want to bring the bad stuff into robots.
We're going to talk a bit about bias but we're going to take a question that is related to what we're talking about right now. So Lars writes to us and says, language is a basic aspect of social being. If AI system robots shall become truly social, don't they have to develop a common AI language in order to communicate with each other and humans? And you also have to address here what an AI language could be. So what do you think about language?
Well, when we talk about language, clearly, yes, it's a part of human behavior, how we communicate. We don't just use our body, we also speak. So robots, in order to be successful in an interaction, need to be able to be programmed in order to understand what people are saying. And this also still comes with challenge when it comes to natural language processing or understanding. All those systems are getting better. But nowadays in research in this area, there are also other modalities other ways that the robot can infer what a person is saying. For example, through the support of text-based interaction or using multi-touch screen. Then there is the kind of interpretation of what people are saying, and also the planning of what to do next. So again, it's this, if we go back to this definition of an artificial intelligence that we talked about in the beginning. So robots need to be able to act in an environment by perceiving humans in the environment, understanding them, and planning some actions according to specific objectives. So it is complex, but indeed is crucial in many applications where human communication, speech-based communication is key.
So how do you go about to design a social intelligent robot that can interact with humans? So how do we do that?
Yes, so in many of our works where we design let's say skills for robots to interact successfully with humans in a certain application, we look at how humans work in that application. I have done some work on robot tutors to support children in the classroom as well as teachers. So one approach is to go out in the real world, understanding how teaching and could work in a real human environment, looking at how behaviors that the teachers adopt while they are trying to support learning with children. So we look a lot at real humans, and we borrow from them, especially when it comes to behaviors and communication. And of course, the robot itself needs to have a body that supports that. But there are interesting questions as well here. So how can we transfer models from human-human interaction to human-robot interaction if the robot's body is limited? I think this is really fascinating.
What do we know today about this? Where are we in the field and in the knowledge regarding this?
Well, as I mentioned, I think that the extent to which robots should be human-like in how they behave is still an open question. Again, we know that very human-like robots can be advantageous for a successful interaction, but robots that are too human-like, but they do not reach human level of human likeness, then these robots are quite disliked, and this is something that goes by the term of uncanny valley effect. On the other hand,
what is that?
It's basically, this is a phenomenon that occurs when a robot's body is very human-like. Think about androids robots. And there was one in the slides I showed earlier. These robots might look really like humans, but as they start to move, you immediately figure out that there's something that's not quite right. So when there's this tension between, very human-like appearance and perhaps not very human-like behavior, then this creates a little bit of discomfort in people. So then we might not like them so much.
So on then the other hand, better to make a robot that is completely non-human-like.
Well, there are works that claim that as long as robots can fulfill a certain purpose or function, then it doesn't really matter that they have human likeness. But there's a large body of evidence also pointing to the fact that human likeness, to some extent, is also is very important and for acceptance. So I think this is very context dependent. So we might not really need extreme human-like robots in certain applications, but perhaps other simpler versions could also function as well. So very much context dependent, user dependent. There is no single solution for all applications.
Amir has a question here. Can these robots show empathy as much as normal humans do?
Empathy is something that I'm interested in my research. And it's crucial when it comes to implementing social behavior in robots, social intelligence behavior. So the ability of putting yourself into another person's shoes. It means really to try to understand what another person is experiencing and also to generate a response. It could be the way that the robots speak, what it says, or whether it uses facial expressions or body movement that in a way that they align with the human interaction partners. There are different levels of empathy abilities that we can program in robots. But this is, it is quite important, especially when we think about robots in socially supportive roles.
So if you would like to give an example what an empathetic act from a robot could be.
Yes, one example from my research is a robot tutor that tries to understand if children in the classroom are experiencing difficulty during a learning activity. And then if they do, then the robot can decide to intervene by providing some encouraging comments or by changing the level of the teaching activity and adapting to each child's situation.
We have a question here from Olaf that will bring us into the new area to discuss. He writes, how autonomous are the robots? If they are, who is accountable for their actions?
Yes, so autonomy is definitely one of the other big questions in social robotics like right now. We still have robots with fairly limited autonomous abilities, but with the advances of artificial intelligence, now robots can do more and more things, let's say, without human intervention. But as you say, it is a crucial question. In research, first of all, it's not always necessary to develop robots that are autonomous. There are some questions that we can easily answer by having a human teleoperating a robot and in a context that allow us to understand how people react to a robot. But this is something different from developing computational skills and also assess how they work in a real robot interactions. And here there are other questions that are relevant. How autonomous should robots be? That's again is very much context dependent. Should there be human oversight? Should humans be able to control to some extent the robot, to intervene if something goes wrong? Or should there be things that robots should not be able to do but only with the control of a human. So these are questions, the degree of autonomy of a robot and an interaction with or collaboration with a human that we need to explore further.
I come to think about ethic and trust. And I know there's these questions that you have been thinking about a lot. So if you think about robots, and what are the most important ethical questions to work with today? And what is your take on trust in this?
The European Commission has issued a set of ethics guidelines for trustworthy AI, artificial intelligence, a couple of years ago. The social robots are a type of AI system, so some of these guidelines are very relevant. And what these guidelines state is that a trustworthy AI or robot should be lawful, ethical, and robust. And there's all of a set of requirements that are mentioned in these guidelines that should be followed in order for an artificial intelligence or robot to be truly trustworthy. I mentioned a few, for example, fairness and non-discrimination, inclusiveness, so the need for a robot to work for any user group, irrespective of gender, age, ethnicity, disability status. The importance of reducing bias. There's a lot of possibilities for bias when we use a data set for training machine learning algorithm for AI and robotics to do things in the world. So these are really, really crucial topics that researchers will have to address more and more in the future. Transparency. How do we know why a robot has made a certain decision? How do we know whether it has understood something about us? We don't want robots that are black boxes that really act in the world or in interaction with us without making it really clear to us what is their intent. And also, again, I go back to the issue of autonomy and oversight. That's also quite important for humans to be in the loop, not only when it comes to designing robots, but also in all phases of development, deployment. Where should a robot be, but where should a human be able to intervene? And what should a robot do and not do?
So what are, I mean, robots, these kind of robots are entering our world today on several different levels. So what are the laws saying today about accountability? When is a robot accountable? Can a robot be accountable?
I think this, again, it's a question that I really hope our society, not only researchers, will address more and more in the future. We need clearly regulations, and still, I'm not a lawyer or legal expert, but there is no much about accountability out there, especially when it comes to new artificial intelligence and robotics. What if these systems make mistakes, sometimes fatal mistakes? Whose fault is it? We'll see. It's really up to us to make sure that we fight in order to have policies that support AI that works for humans.
I know you have been working a lot in projects related to education, e-learning, assistive devices, and all of the projects I read about that you've been doing is for actually empowering people in the society. So what is the biggest benefits a robot can have today for a human being and a society, as you see it?
I think that there's a lot of potential for robots in socially assistive roles. So what we are looking at here is not the design of robots that replace humans, but as you say, that they empower them. And I'll take as an example the robot tutor example I gave earlier, because that's what I have been working on for several years. Robots can be very engaging tools that can be used to support teachers in the teaching of STEM topics. For example, we looked at
So that is topics related to technology, maths, and
science, precisely. So robots that can be, again, used to create the new applications, new scenarios that can be included in a teaching context to support the teacher's teaching. When it comes to, again, STEM topic, we have worked with teaching kids geography, with teaching kids sustainable development issues. And if kids do this in a fun way with their social robots, perhaps with games, with a cooperative game with the robot, they learn in a much, with a lot of fun.
So how does that work practically? Do they have a robot in front of them that are guiding them into knowledge, or are they asking the robot question? How does it work practically?
Yes, typically we would work with what we call a face-to-face interaction. So the child or children would be in front of a robot. We could think about also having the support of other technologies, such as multi-touch tables or big tablets, where children can work on different kinds of activities. We also had more recently a robot supporting children in creating stories. And there are characters on a tablet that the children can select and then use to create a story together with the robot.
Is there a benefit of using a robot instead of a human, or is the robot there because we don't have enough humans?
Yes, so that's also a very important question. So in general, I will say we are not working towards building robots that replace humans, but to support them. However, there are always cases where perhaps we don't have enough labor. This goes beyond the case of open education, but we think about teachers. Could there be situations where we need a child to be assisted, but there's not enough personnel? Think about a child learning at home and needing some support in reading. So that's learning that doesn't happen in the classroom. Someone cannot necessarily be there all the time. So you need to identify cases where clearly there is a need for someone to be there. But this comes with challenges too, because humans can also develop attachments towards robots, to create asymmetrical relationship. We think about vulnerable populations, children, the elderly. This is always the risk that they also attribute more capabilities to the robots than the ones that they have.
They'd rather be with robots than with humans. But we have a question. I would like to bring that in before our time ends today. And it's from Amir, and he writes, can robots with social intelligence research lead to a potentially improved social skill program for people having autism? Is there already a link between these two fields of research?
Yes, there is. And I have never worked on applications using social robots in therapy and support of people with autism, but there is definitely a lot of research, and especially with social robots. So playing a role, for example, of mediator with a human during communication training and nonverbal communication training in interaction. So definitely there is, and it's one of the powerful applications of social robots today.
Mikael writes, do you work with other projects or research groups in the field of research? And he has an example from KTH that is called Furhat Robotics.
The question is about the Furhat?
If you do work together with other research groups in the field.
Oh yes, that's what we do. We work with we have collaborations within Sweden, Europe, and other continents too, and that's part of the research. That's what makes research excitement, and what makes enables advances, the interaction and communication with other researchers. And you mentioned Furhat Robotics. It's a company that we know very well. We have bought a few robots from them, and the Furhat robot is currently one of the robots we used in research, in education, for example.
Last question. Where do you see social robots in 10, 20, 30 years?
Well, I will say what I would like to see. I would like to see more social robot development that really make sure that we design robots that work for us. Again, going back to what we have discussed about ethics and about trustworthy AI. We want technology that really works for us and doesn't take us where we don't want. As you say, as we know, technology is already changing us, and sometimes in ways that are not so good. And of course, there is the potential for this to happen with any technology that we build. So that's especially because of this that we need to be careful that we know where we want to go in the future.
Thank you, Ginevra. Thank you for joining us. This half hour just disappeared.
Yes, went very quickly.
Next week, AppTalk Weekly will be in Swedish, and it's the last Tuesday of this month. So we're going to learn more about a collaborative project conducted with Uppsala University and together with an external actor. We will meet Johanna Liljenfelt, Associate Professor at the Department of Earth Sciences at Uppsala University, and Elin Slättmo, Senior Researcher at Nordregio, an international research center. Johanna and Elin will join us to talk about their shared project, focusing on locally owned energy projects in Sweden and the role they can play in the conversion to sustainable energy systems. With this, Ginevra and I wish you all a good week, and thank you for joining us today.